For lesson 79, we're dealing with transforming formulas. If we do a little review, if we had x is minus 4 is equal to 7, this was just a simple one-step equation where we want to get rid of the minus 4, so we would add 4 to both sides. Let's get x is equal to 11. And today we're going to do the same thing. We're solving equations, but instead today we're going to be dealing with just strictly variables and solving for a particular variable. So for example number 1, it's given that w is equal to x plus b. Now we have no idea what w, x, and b stand for, but that's okay. The only thing that we do know is that we want to solve for x. So the objective here is to get x by itself. So if we look at the right-hand side, we identify, yes, that is where the x is located. So that means we need to get rid of that plus b. So w is equal to x plus b. We need to get rid of that b. If we're adding b, just like if it was adding 4, we would subtract 4 to both sides. So here we're going to subtract b to both sides. So here we have x on the right, and I have w minus b. And again, they're just variables. You can't simplify those, okay? We can't take 7 plus 4 to get 11 in this case. So we're just going to leave it w minus b. And if you want to, you can write the x first, and then just write w minus b. So that's going to be the problems for today. It's just simply doing the same process that we've been doing, except now instead of doing the using values, we're just going to simply do it with the variables. Here for example number 2, we have c is equal to d times pi. Hopefully you're recognizing that's our circumference formula, diameter times pi. And here we want to go ahead and solve for d. So again, right-hand side of the equation, we recognize that's where the d is located, so I need to get rid of that pi value. Now notice the operation between d and pi is multiplication. Therefore, we want to go ahead and divide both sides by pi. So d is equal to, or c is equal to d times pi. We need to get rid of the pi we're multiplying. The opposite of multiplication is division, so we'll go ahead and divide both sides by pi. And again, we don't know what c is, and that's okay. So c over pi is equal to that d value, or if you want to, d is equal to c over pi. Example number 3, a is equal to lw. We want to solve for L, and then we're going to evaluate. So they added an extra step on the end here that we're going to evaluate when A is 42 and W is equal to 3. And that's quite all right. Let's go ahead and solve this equation first for L. We have A is equal to L times W. Again, the inverse of multiplication is your division. Therefore, we need to get rid of the W. Therefore, we're going to divide by W. The W's cancel. We have A over W is equal to that L. Or once again, if you want to write that variable first that you solve for, you can say L is equal to A over W. Now the second step is we're going to take this newly created equation and we're going to go ahead and plug in 42 for A and 3 for W. And now that we have values, now we can go ahead and simplify this thing. 42 divided by 3, we get L is equal to 14. So just one extension off of that. We have one more that we're going to take a look at here, and then I'll let you work on your practice set. We have A is equal to pi times radius squared. We want to solve for R. Now notice there's two things that we need to get rid of here. We need to get rid of the pi value. We also need to get rid of that exponent of 2. So which one do you do first? Well, it's the reverse order of operations. Typically, we start with that exponent of 2, but understand when we solve, we actually save that for last. We're actually going to divide both sides by pi first. So we have A over pi is equal to R squared, and now we need to get rid of that exponent of 2. Now this goes back to the very first semester when we talked about exponents and how we get rid of them. Pythagorean theorem, how do we get c by itself? Well, we have to take the square root of both sides. Therefore, if I have a over pi is equal to r squared, I simply need to take the square root of both sides. Those two cancel, and I get the square root of a over pi is equal to r. Or r is equal to the square root of a over pi. So that's the gist of the lesson. You are solving equations once again, but now you're just doing it with variables instead of values. And then whatever expression you come up with, that'll be your answer. I want you to work on practice set problems B as well as C.